Good afternoon, everyone. This is our seventh lecture of mat1001. Today, I will go to explain similar triangles, a little bit more information about triangles, and then I will start to trigonometry. Okay, our topic is similar triangles. How we can say that two triangles are similar? Two triangles are similar if all the angles are equal and sides are proportional. So if all the angles are equal and the sides are proportional, we can say that two triangles are similar. So, for example, here, as you see, A1 and A2, B1 and B2, C1 and C2 are proportional. Means if A1 is 3, let's say A2 is 6. If B1 is 5, if the proportion is 1/2, so B1, if B1 is 5, B2 must be 10. If C1 is, for example, 6, C2 must be 12. And if this angle is 60 degrees, this angle should be 60 degrees. If this one is, for example, 40 degrees, this should be also 40 degrees. And same for the third one. Okay, here there's an example. It says that show that the two triangles given in the figure below are similar. So how we can show that they are similar? Let's see. We know all the lengths. So we can check if they are similar or not. So let's say length PQ. Let's check length PQ and AB. PQ over AB is 6/2 is 3. Let's check for, it is checking QR. QR with BC or CB. 12/4 is 3. And last one, PR with AC, 15/5 is 3. So because of all the lengths are proportional, have same proportion with each other, we say that these two triangles are similar. Okay. The other example, show that the two triangles given beside are similar and calculate the lengths of sides PQ and PR. So, only one side of bigger triangle is given to us, the length. Which one? QR is given. And from this, we can just, of course, we know that the two triangles are similar. We know that property. So if this one is 12 and this one is 6, so the proportion should be 2. So if this one is 4 and the proportion is 2, this should be 8. And if this one is 7 and proportion is 2, this should be 14. So in the solution, let's see. Of course, you have to check this angle symbols. This angle is equal to this one, and this angle is equal to this one. And of course, the remain will be same. So if this is 60, this is 50, this should be 70. If this is 60, this is 50, this should be 70 as well. So all these angles are equal. This one, B with Q, A with P, and R with C. These symbols are angle symbol. Okay. So if they are similar, the proportion must be same. So AB over PQ must be equal to BC over QR and AC over PR. So from here, we can easily find the other sides of bigger triangle. Another example, find the length AB in the triangle shown beside. So here we have two triangles, and because of the smaller one is a kind of subset of the bigger one, like that. So we can easily say that they are similar. We know that BC is 3, DE is 6. And it is asking to me to find the AB. Okay, we can easily again apply the rule of proportion. Let's check. BC over DE is 3 over 6. So AB over AD should be 1 over 2. But we know that AB is something that we don't know. We know BD. So for this one, we can say, instead of AD, we can say AB plus BD. So here, AB over AB plus 4. We know that this side is 4. So there's only one unknown here, AB. So we can easily find from here that AB is 4. Given the shape shown by the figure beside, find the length AD or X. Okay, this is almost same. So if ED over AB is 7 over 11, we can say that AD over sorry, CD over CA should be 7 over 11. Almost same question. Okay, DE over AB is 7 over 11. CD over CA is 15, you know, this side, over CA. But instead of CA, to make it only okay, we know 15 over CA. Yes, so we can easily just, there's only one unknown. 15 over CA is 7 over 11. So we can find CA as 23.58 CA. But question is asking to me to find AD. So how I can find? Just I have to subtract from 23.58 to 15. And the result is 8.57. Okay. The next topic is trigonometry. Okay, we will make an introduction to trigonometry today, and next week we will go more further. So, what is trigonometry? It comes from the Greek word trigonon, which it is in English triangle, and metron, which it is in English measure. So the word is in English is triangle measure. So this is related with measuring the triangle. Okay. So the main part of the trigonometry is the right triangle. And there are several special names that define the ratios. So we have sinus, cosinus, tangent, and it is related with the adjacent side, opposite side, hypotenuse. So let me to explain these things. So sinus theta is actually, it is a value. So this is a way of we can find by just measuring the angle at one side, for example, and we can find the other side. So if you remember from hypotenuse Pythagoras theorem, if we know if it is a right triangle and if we know two sides, we can find the third side length. But here, we don't need to know two lengths. If we know one angle and one side of the triangle, we can find the others. So if I am looking for sinus theta, I can easily find by dividing the opposite sides of the angle, dividing by hypotenuse. So sinus can be found by this way. Then the cosinus can be found by checking the, look, this is the opposite side of the angle. This is the adjacent of the angle, and this is the hypotenuse, the longest side of the triangle. So cosinus is adjacent over hypotenuse. And the tangent theta is opposite over adjacent. And it is continuing. There are more, but we will explain them later. Okay, let's discuss why this right angle triangle is so important. So imagine we can measure along and up, but want to know the direct distance and angle. So we have some missing parts in our measurement. So I know this one, I know this one. I can find this side, but how I can find the angle? So by knowing this length, you can easily find it by applying that formula. So trigonometry can find that missing angle and distance. The other thing is, or maybe we have a distance and angle and need to plot the dot along and up. Okay, here, for example, we know this length, we know the angle, but we don't know this side and this side. So, of course, by using trigonometry, we can solve it. So, questions like these are common in engineering, of course, architecture, computer animation, and more. And as I told you, by using trigonometry, we can find the answer. So here, there's a question. What is the sine of 35 degrees? I have to show the solution because I just wrote here the figure. I didn't think that. Okay. What is the sine of 35 degrees? We are looking for sine 35 degrees. What was sinus? It was opposite side over hypotenuse. So what is our angle that we are looking for? 35 degrees. So the opposite is 2.8 divided by hypotenuse 4.9. So sinus 35 is 0.57. Of course, it is approximately. Okay. Another question. How tall is a tree? So we can't reach the top of the tree, but we want to know how tall is it. So we walk away to a distance that we can measure it, and we can measure the angle with a protractor, and we can measure this distance with a laser. So here, now it is the same question. I want to know this length. So sinus 45 is opposite side over hypotenuse. What did I say to you? If you know one angle at one side, you can find all the angles and all the sides in a circle, right circle. So here, we can easily find sinus 45 by checking from calculator. Okay. Also, there are some tables for that, but easily we can just, if you have a scientific calculator or in computer, you can open your calculator and check it if it is scientific or not. You can switch it to scientific mode. So by using calculator, when I type 45, then click to sin K, then it will give me this result, 0.7071. So when I put it to this equation, the opposite side will be 14.14 meters. So we can easily find this height. Okay. Let me to give you a few information about this topic. 1 degree is actually 1/360 of a full circle. So, as you know, the whole this area is 360 degrees. That's why it is 360. Each degree each 1/360 is called as 1 degree of a full circle. So minutes, as you know, it is, if you have classic watch, you can see 1/60 of a degree is a minute. So 1 degree is 60 minutes. And 1 second is 1/60 of a minute. So 1 minute is 60 seconds. Okay, these are not so important for now. We will see it later. But just I gave you an information. Quadrant is the division to 4 parts of a circle. So circle is divided to 4 parts, and it is just labeled by using Roman numerals, and numbers are counterclockwise. What does it mean? It is the opposite side of clockwise. Okay. Okay. From 0 to 90 degrees, it is first quadrant. Okay. And if you remember this X and Y axis, this is positive, and this is also positive side, if you remember. Okay. The second quadrant is 90 between 90 and 180, and it is, as you see, positive between positive y and negative x. This is a negative side. So if you, for example, count 1, 2, 3, 4 like that, this should be -1, -2, -3, like that. The third quadrant is between 180 and 270 degrees. And both sides are negative, -x and -y. So the fourth quadrant is between 270 to 360, and it is positive x and negative y. Okay, this will be important later. The other thing is radian measure. As you see, this is a circle. This is the center of the circle, and this is the radius, and this one is also radius. Okay. If, of course, there will be in each circle. When you make this kind of pie, of course, each part, each line just drawn from the circle to the edge of the, from the center of the circle to the edge of the circle is radius, is r. But if this arc length is r, it is called and this angle is called the radian. So 1 radian is the measure of the central angle whose length is the same as the radius of the circle. So if there's a kind of pie that radius is same with this one, this arc, this angle is a radian. Okay, this is called radian measure. Okay. What is the relationship between radians and degrees? So here, this is angle ABC, this angle. Okay. Over 360 degrees is equal to this arc AC, this length over circumference. So the circumference. So this angle over 360 is this arc over circumference. So this is a relationship between angles and the length. So in 1 radian, this angle, if it is 1 radian over 360, and if this is r, as you know, if it is 1 radian, this should be r, like this. So circumference formula is 2 multiplied by p multiplied by r. So we can easily find that p multiplied by radian is equal to 180. So 2p radian is 360. So this is a formula that we just, as you see, developed from this small property. So in the equation, convert the following angles to radian measure. There are 3 angles. 60 degrees. We know that P radian is 180 degrees. So what is 60 degrees? We can easily find that it is 1/3 P radian. Okay. So P is a number, of course, is a constant. We can also put P here and we can find another value, but both of them are same. This is a kind of value that we know it, but we didn't calculate it yet. But of course, you know, it will give the same result. Same P radian, we know that it is 180 degrees. So 125 degrees should be 125 multiplied by T radian over 180. This is the ratio proportion rule. So the result will be 3/4 P radian. Here, P radian, we know that it is 180. What about 206 degrees? For here, you know, it is same, but just a different thing. Here, we just put P here. So in the equation, if it is asked, we can either let it as P or we can just multiply it. So we find that it is 3.60 radian. Here, convert the following to degree measure. So it asked me this one to make it degree. So in the previous question, it was giving us the degrees and we are just giving it as measure. So here, the measure is given us and it is asking for degree. But as you see, we are using the same thing. P radian is 180. So 2p/3 radian is what? So I have to multiply with 180, this one, and divide to p. So when we put it into equation, at last p's are eliminated and our degree will be 120. Okay. 1.62. Now look, this one we put p. I can either multiply it with 3.14 and make it like that. Here, maybe this will be not complicated, but a little bit confusing. But same formula, if P radian is 180 degrees, 1.62 is what? 1.62 multiplied by 180 divided by P. So 1.62 multiplied by 180 over 3.14 will be 92.8 degrees. So as you see, we can easily convert the measurement to degrees or degrees to measurements in a circle by using this small formula. So the arc length. The length of an arc in a circle is equal to the size of the angle in radians only times the radius of the circle. So the arc length is the angle multiplied by the radius. Okay, here it is asking calculate the arc length. So I know that this is 2.7 radian and this is 5 centimeter. So that formula is not, if you remember in the beginning, if this is R, this is R, and this one is R, this is 1 radian. But this is not like that here. It is not 1 radian. So it is 2.7 radian. So I know the radius, I know the radian value, so I can easily calculate the arc length. What is the arc length? This is the arc length, 13.5 centimeters. Okay, normally this lecture should be about 2.5 hours because I had to give you the questions and then you have to answer, then we have to discuss. But sorry for today, I have to make it like that. Please do all the examples, and as you know, I told you next week I will give you a quiz from the beginning to this point. So you are responsible from all of them. Please study. You can disturb me anytime. You can ask me anything about the lecture. So please, this weekend, check this video. If you have any misunderstandings, for example, Monday or before Monday or Tuesday, it doesn't matter for me. We can make another lecture, for example, for 1 hour or like that. It is online, so it doesn't matter. So please just check this video and ask to me if there's any question. Okay. Have a nice weekend. Bye-bye.